Okay, I welcome you all to this Math 371 lecture 2, which is actually unit 4.3 numerical integration. And today we will discuss how to implement the numerical integration on MATLAB. So before I go in detail, I will write to the formula for you because we have missed the lecture. So at the moment, just two formulas for numerical integration. And what I mean, the first is like a trapezoidal rule, and the second is Simpson rule. And now I will say what is trapezoidal rule and Simpson rule. So I will try to use the pen for you, but maybe the drawing is not very good at the moment. So I ask you to please neglect this part, but the point is you understand not. Or so the idea is we are going to integrate from a to b some function f of x dx using the trapezoidal rule. So this is some kind of approximation. So in the last lecture I explained in detail how the formula has been made using first linear Lagrange polynomial thing, and the formula was h over 2 into f of a plus f of b. So what is f of a and f of b? So we have given some function f of x and defined on this interval a and b. So now the question is that how we will integrate numerically using trapezoidal rule. So this is the formula. Okay. And what about the Simpson rule? What about the Simpson rule? So if you want to say what is the Simpson rule, so from a to b, f of x dx is approximately equal to h over 3 into f of now I say this is like x naught plus 4 times f of x1 and plus f of x2. So what I mean by this thing, I will explain little for you so that you have understanding. So here the h was only b minus a, but here h was b minus a over 2. So so in principle over a is over x naught, and for the trapezoidal rule b is over oh, I should remove this for you. So whatever is over x1, which is actually it will be b. So moreover, if you want to see what is x1, so x1 is actually x naught plus h. I hope you got the idea. And here h is this one, okay, but now we will see what is f of x naught, f of x1 and f of x2. To do this I will use another color. So this is nothing but an f of a, this is nothing but a f of x naught plus h, and this is f of b. And moreover, what is b? So a is like x naught and this b is like x0 plus 2h, and this is equal to x2, and this is equal to b. So now this is the formula that we have seen in the last lecture, that how to approximate a given f of x in the interval a to b using trapezoidal rule and using Simpson rule. So for the trapezoidal rule, the h was b minus a, just for one interval, and for the Simpson rule, h is b minus a over 2. So it is like the average, because we have now 3 points. 3 points means we have two intervals from x0 to x1 and then x1 to x2. Okay, so now we have developed, or we have seen at least what is the formula for trapezoidal and Simpson rule. Now the question is that how we will solve the questions. So for example, in the book we have example number one, if I remember correctly. So example number one, and what was this? You have given f of x is equal to x, and then you have given the interval from 0. Okay, and he asked us to find the numerical integration using trapezoidal rule. So trapezoidal rule. Okay, and then he asked us to find the same using Simpson's rule. And now for example, okay, what was the trapezoidal rule? Now we have a naught from 0 to 2 and f of x. Okay, I will write f of x dx. So this is equal to h over 3. So now what is h? 2 minus 0. So 2 minus 0 over 2. Okay, and what is f of? So here a is 0 and b is 2. Okay, so what is f of a? F of a will be x square, because f of x is x square. Okay, and then plus say f of b. So b is 2 here, so but f of x is x square, so 2 square. So 2 square. So when you simplify this factor, this 2 is cancelled out by this 2, and 0 square is 0, 4. So the answer is 4 for the trapezoidal rule. Now we will see what is for the Simpson rule. The same question using Simpson rule. So 0 to f of x dx. So this is actually in principle some kind of approximations. So we write like this. So he say h over 3. Now what is h here? So here we have seen for the Simpson rule, the h is b minus a over 2. So now b is 2. 2 minus 0 is 2. 2 over 2 is 1. So h is actually 1. 1 over 3 into, we say f of x naught. So f of x naught means 0 square, because x naught is 0. So 0 square plus 4 times f of x1. So what is x1 here? So if you want to write, where you want to write for Simpson rule, what is x1? So x1 is, you see, x naught plus h. So x naught is 0 and h is 1. So 0 plus 1 is 1. So f of x1 is f of 1. So where it is x, you put just 1. So x square means 1 square. 1 square. So this is f of x1 plus f of x2. So over x2 is over b, which is 2. So 2 square. Now when you simplify this, you will get 4 plus 4. So 8 over 3, and you can approximate the value. So this is how we have calculated the number. And if you see what is the value, 8 by 3, so you just compute or using your calculator, or it will be 2.66666, and so also we round it 2.667. Now if you want to say what is the exact value, so because we are just approximating the things, so we need some other color. Okay, we write this in green. So we want to see that what is exact. So exact value, so it is the from 0 to so 0 to 2, and f of x dx is equal to 2. What is f of x? Is x square. Dx is equal to, now what is the integration of x square? X power 3 over 3, and from the limit 0 to 2, so you plug this 2 here, it will be 2 power 3. So 2 power 3 is 8. 8 over 3 minus 0, which is equal to 8 over 3. So you see what is 8 over 3? 2.6667. So we have the same answer. Like Simpson rule. So Simpson rule is somehow give us the exact value when we have a square, means is quadratic polynomial. So if you remember the book, we have the error something like in the third derivative. So the third derivative of this function is 0. So for the second derivative, it gives us the exact answer of what is the solution. But whenever this function is more than degree 2, there will be some error. And for degree 2, we give the Simpson rule give us the exact value. So this is the idea. And I hope now you understand this very clear, that rule, what is Simpson rule, and then how to find the numerical approximations for this using any function, and then you can compute the error as well. So what is will the approximations? You can see the approximations for the trapezoidal rule. It will be 2.667 minus 4. So it is lot of error there. But for the Simpson rule, 2.667, because 8 by 3 is the same. So we have the exact solution somehow, because of the fact that it is just a square. And for any square polynomial, the Simpson rule give us the exact value. But if there is any function like sine, cos, e to the power something, log, and more than x cube, then the error will come there. And to find the error term, we will do in the next time. And one more important question is this: we have just taken 3 points, x0, x1, x2, interval of AB to more than 3 points. So this is like 4.4. We will do this inshallah on Sunday. And now I will ask you that if you have any question, you can say it. Dear students, there is no decision about the major 2 and final 2 at the moment. So we will like that we will teach this online, and at some point when the things are finalized, we will announce you. So for the major 2, you please forget at the moment. Actually supposed to do the content of the course and complete the course first, and then we will have a quiz and the homework online. And for the major, there is no decision at the moment. So some student is asking B is x1. So when we are using the Khalid, Mr. Khalid has asked me a question. Did you say that P is equal to x1? Then how come is Simpson rule x2 is equal to B? Because we have talking about two methods. For trapezoidal rule, x1 is B. But for Simpson rule, x2 is over B, because in Simpson rule we have 3 points, but in trapezoidal rule we have 2 points. I hope you got my point. Any other question? Okay, so there is no more question. Then now I would like to do the other part. And the other part is that how we will do this on MATLAB. So I will like to share with you. So I'm doing something for you. I'm trying to open the MATLAB editor for you so that we can solve the numerical integration questions using MATLAB. So now I have open an editor for you, and I hope you can see it. And just to revise you the formula, what we have done numerical integration using trapezoidal rule. So this is f of x1 is over b here, and this is the error term x cube over 12 and the second derivative. And then for the Simpson rule, we have this x from x0 to x2, and we have solved this a part, example number 1, and I am supposed that you will do the rest of the parts and the homework when we upload. And now we will see that how to do this using numeric array on MATLAB. Okay, so I open a new file for you. So first of all, we write CLC and then clear all as usual, and then close all. Just clear is enough. Now, what is our target? So we want to solve numerical engines of the Trapezoidal rule and integration and Simpson rule. So please be patient. Some students are asking some other things, but first of all we focus on this lecture, and at the end of the lecture I will ask about the questions if you have, and then you can ask any question about the course and what we are going on. So at the moment please pay attention to this.
You can't see the.
So uh, you can see this math editor.
Oh, well, I'm guessing what, you know.
I hope you see the MATLAB editor. Okay, let me do this again for you. Can you see it now? I think there is some problem, but just let me see it again. So I have closed the MATLAB thing and will start it again to have a smooth startup. So in the meantime, I will go back what we were doing on this note 1 and let you know how to do this. So now you can see at least the one node. Agree? No, you cannot see anything. So there is something wrong because maybe there is some connectivity problem. Let me, this is some two problems.